Hi friends, I am Shravana and welcome back to my channel Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, today we will discuss whether executing Hive queries in Spark give us any benefits. If so, why? Why do we have the benefits? Okay, that topic we will discuss today. So coming to the benefits part, right? So you can see potential time benefits when running Hive queries from Apache Spark. It's due to the integration and optimizations provided by Spark execution engine. So when you are executing Hive queries using Apache Spark, right, it leverages Hive metastore and supports reading Hive tables directly. This integration allows you to take advantages of Spark's powerful distributed processing capabilities, which can significantly improve query performance for large datasets. So, what are those potential time benefits when we discuss, right? So, what are the benefits that we get from Spark, right? It is the first one is in-memory computing. We all know that the Spark is known for its in-memory computing. So why it is a benefit to us is Spark can cache the intermediate data memory by reducing the need of disk IO and improving overall query performance. This is particularly beneficial for iterative or multiple step queries where intermediate results can be reused. Okay, and also we all know that Spark works on distributed environment, so it provides a potential benefit which is the parallel processing. So Spark enables distributed and parallel execution of Hive queries across a cluster of machines. By breaking down the query into smaller tasks that can be executed in parallel, Spark can process data more efficiently and complete the query faster. Okay, and Spark also provides advanced optimizations like catalyst optimizer and then pruning and predicate push down, right? So these optimizations can result in reduced data transfer and minimized processing, which leads to improved query execution time. And also we have this data locality concept in Spark. This Spark's data-aware scheduling can leverage data locality information to schedule the tasks closer to the data they need to process. This minimizes the network overhead and improves the performance by reducing data movement across the cluster. And also we know very well about the Spark ecosystem, so we can integrate, like we can seamlessly integrate with other Spark's ecosystems, and anytime we can leverage this Spark data frame API for data manipulation, and then we can use streaming for streaming the same data that is read by Hive, okay, read from Hive, and we can apply machine learning algorithms on top of it, so we can utilize any component from the Spark ecosystem. Okay, so running Hive queries from Apache Spark can provide time benefits due to Spark's distributed computing capabilities, as we discussed, in memory computing, parallel processing, and then it has advanced optimizations and so on. Okay, so let's say we are submitting one Hive query from Apache Spark. Okay, read table, perform some kind of operations, maybe something we are doing. I mean, we are reading a table from Spark, let's say. Then what happened? What all components will be participated in this execution, right? Let's discuss that. So, in the background execution of a Hive query, what all components will be participated from Spark and how they will benefit us. So, we all know that Spark driver is the main controlling component responsible for executing the query. Anything, okay, not only for the query, any command that we receive from the client, driver is responsible for controlling this execution. Okay, it receives a query from user or anywhere from the cluster, and then it interacts with the Spark session and initiate the Hive query execution at this point. Okay, next, what is this Spark session? That we all know, Spark session is the entry point to the to Spark cluster, where it interacts with the Spark functionalities and integrates with external systems like Hive. It also manages the configuration, resources, and the context for executing the Hive query. And this Spark session handles the communication between driver and the cluster's executors. So what kind of communication it will have? It makes the plan, and based on the plan it requests the executor, saying that the application master saying that, see, this is what my query is, I need this much configuration for running that. So that kind of communication it holds, and it helps in proper planning of the resources, and which results in improved performance of the query that we are executing. Next one coming is Hive Metastore. So the Hive Metastore is like a central component that stores the metadata about Hive tables, partitions, columns, and any other database related information. When executing a Hive query from Spark, the Spark SQL module interacts with Hive Metastore to retrieve the metadata for Hive tables, and it optimizes the query execution. And then what happens is, Hive execution engine is responsible for executing the Hive query logic. And when we are submitting a Hive query from Spark, the query plan generated by Spark SQL is passed to the Hive execution engine. And this execution engine performs various optimizations, like if there is any query rewrite. For example, if we are doing the join first and then filtering out, then it will do that pruning, partition pruning, and also the push downs, predicate push downs and all. And also it provides some statistics based optimizations, and it generates an efficient execution plan. And then comes to our main heroes, which are Spark executors. So these Spark executors are the worker processes running on the cluster's worker nodes. These executors execute the tasks assigned by driver. So in our case, we have the plan ready. So this receives the tasks generated by the Hive execution engine and executes them in parallel across the available resources. Okay, each executor processes a portion of data and returns the results to the driver. Then finally the HDFS. So this is the distributed file system, which is like a bridge for both Spark and Hive to store the data. So when executing a Hive query from Spark, so we have to, even though we are reading from Hive, but ideally the data is stored in HDFS only. So the Hive query execution interacts with the HDFS to fetch necessary data blocks, and then it writes the results to appropriate HDFS locations. So all these services work together to execute a Hive query. Okay, and the driver coordinates the process, session integrates with Hive Metastore, and then manages the query execution, and Hive execution engine performs query optimizations, and then the execution logic, I mean it actually performs the optimizations mainly. And then once the plan is ready, the main execution of the tasks will happen in parallel in the Spark executor, and finally the data will be returned back to HDFS. Okay, this is what happens when you run one query, Hive query in Spark. Actually it's common anywhere, but here Hive is extra. Hive Metastore and Hive execution engine are the extra components that we are talking about. Okay, and now we have just seen like what exactly will happen on high level in Spark cluster, right? So now let's see what exactly will happen, how the parsing will happen and all, right? When you submit the Hive query through Spark. So what will happen is, this Spark session, right, it will have already Hive support, because we, while creating the Spark session itself, we will mention that enable Hive support, correct, for using the adding the Hive support to Spark session. Then what will happen is, when you performing Hive query in Spark, the Spark SQL parser parses the query and it converts it into an internal structured query representation called a logical plan. Okay, then the logical plan converts or it captures the operations and transformations defined by the Hive query. Okay, and this is where the exact parsing will happen. And then what is a parser here means which reads the Hive query and which will convert into the machine understandable format. So this is the parsing here. Okay, and then once the logical plan is created, this is, we have anyway Spark's catalyst optimizer, right? So this optimizer performs various optimizations such as predicate push down or column pruning or join optimizations. Okay, and it gives us very good optimal plan, optimized plan. Okay, and this query will be sent to this Hive query execution. So after this optimization phase, Spark's query execution engine takes the optimized physical plan and executes it within the Spark cluster. The Spark driver distributes the query execution task to available executors which are running on the worker nodes. Okay, so now the Spark executor processes the distributed data in parallel manner, right? Whatever query assigned to them. They read the required input data from the underlying storage, apply the transformations and operations designed in Hive query, and perform the necessary aggregations and computations. So these executors work concurrently based on the data partitions, whatever is assigned to those worker nodes. Okay. Then finally, after the data processing result aggregations, finally the results will be collected. Okay, once collected, and they will return the computed results to Spark driver. Then the driver collects the aggregates these results, and then it will present the result to the Hive query to the user. I mean through who user, client, whoever is asking for the results, right, to them it will present. So this is how in the back end Hive query will be executed. Okay, thank you for watching the video, friends. Hope this is useful. Please subscribe to my channel for more interesting learnings. Thank you.